So the next piece of the puzzle is figuring out how much area is going to get inundated with water and what the volume of that's going to be. If you're using Windows, you can go up here and we're going to use the Kriging tool, specifically the ordinary Kriging. And if you search that up, you should see it there, but I'm using a different operating system and it didn't show up, and I spent a while trying to get it to work and I didn't. But what I did was installed Sega GIS, which is another open source GIS program that's much less user friendly, and you can skip the next 30 seconds if you want, but I made a shapefile of our point survey, and I opened it here. So now we got it in there, and we're gonna find and run a tool, and we're going to search for Kriging, and we find ordinary Kriging, and then in QGIS you'll find something that looks a little bit like this. So we're going to select our points. The attribute field will be the elevation. The cell size we're going to change to 5. And we're going to leave everything else to the same. Block. Yep. So we'll try that. So it generates this. It shows the variability of our points. You want these lines to match up closely with this line here, and you'll see if you change this to, say, Gaussian, then you might get a different fit or square root, but we'll just stick with plain old linear for now. Okay, and then down here you can see it's running the tool. It's processing. And it's finished. So this is the thing here. We can add it and see what it looks like. So it looks correct to me, so we can right click and save as elevation, and we want it to be this guy here. And we'll click save, and it's running. Looks like it finished. So now if we go back to QGIS, we can go to layer, add raster layer, raster data set, and we can be more specific on what we want. We can say we just want to look for the Saga file, this guy here. And if we open it, add, close, we've brought it into our program. And change the way that it looks. Pseudo color. Yours will probably be a different color. This is my go-to. Click apply. Put it underneath. And now we have a raster with our given elevations. And so from here we can actually go and do some analysis on this in QGIS. So we can first of all do a contour, and we're going to select the raster that we brought in. There's only one band, and for this we only want one contour line. So we're going to do 100. We're going to go from the elevation, and we're going to go, since we have our berm at 580.00, we'll go 579.9, and we'll have a centimeter of off, or 10 centimeters of freeboard. And we'll just save everything to a temporary file for now. If you wanted to, we should save it to our geopackage that we've already got going. Save it. No. We'll just do a temporary one for now. Click run. And it ran. So this is a contour for the elevation line at 579.9. So you can see this is the area that will get inundated by water. And our berm, let's turn on our points. Seems like our berm didn't work in this particular scenario. We would have had to be more explicit and put more points in here, and probably delete some of these. But we can run with this anyway. And the next thing we want to do is get the volume, raster surface volume. So we can go to our raster 590 or 579.90, and we want below. And we'll just do everything to temporary files and click run. So it's finished, and down here we can see our report is ready to go, and here it is. So our reported volume is a negative, but that should be fine. So if we convert this to acre feet, it's 151 acre feet of storage. And if we convert this acres, we got 75 acres of inundated lands. So now we know what we've got. We had, let's remind me again, 150 acre feet and 75 acres, so 2 feet approximately on average. So that is kind of how we do that. And then we just have a line here delineating the boundary of our inundated area. But if we wanted to get a area of it, we could go here, create new layer, do polygon, and say flooded area, and use data, click OK, create the feature, turn on snapping, enable tracing, and looks like I screwed that up somehow. Go around and round and round. And I'm going to turn off tracing now, actually. There. Now we have the inundated area. I suppose I'd have to draw it again. There. So apparently this is the area that we're going to flood for that particular elevation, according to the most recent data set. Data set's going to change and corrections will be made, but that's kind of how you go through the process of turning points into a known volume and area.